Our next speaker is Miro Vesterinen, a 3D artist from Reborn Games. And Miro is going to talk about the new design workflows in 3D and in games. Welcome.
Right. It's nice to be here again. I was here back in 2014 with a presentation about physically based rendering, which quite drastically changed how we all the texture content. And today, I'm here with a new workflow for globally game assets that I feel has the possibilities to change how we create content now and in the future as well. So the topic of this presentation is custom vertex normals and the medium poly workflow. And before I start, have any of you heard of the workflow before or used it? Just raise your hand. So, all right, few people, that's all right. But before I start, let me tell a bit about myself. So my name is Miro Vesterinen, and I'm a graduate from Kajan University of Applied Sciences, and I also did part of my studies at Decals University in UK. And I'm currently a 3D artist at Reborn Games, and I've been, for the past year and a half or so, I've been working on Urban Empire, which is a political city management game that's published by Calypso Media. But that's really all about me, so let's get to the actual presentation. So the content of this presentation is that at first I'm going to explain quite briefly what normals are in 3D modeling. And after that, I'm going to move to custom vertex normals and a technique called phase fading. And after that, bit how this technique has already been used in production in multiple AAA games, a quick pros and cons list of the said workflow, and in the end, I'm going to show a simple tutorial and show some of the tools for you guys so you can use this in your own projects as well. And if you have any questions, please save them to the end of the presentation. And as a disclaimer, I do not own all the content shown within this presentation, but I already want to thank all the individuals and studios that have shared their workflows and experiences online, making this presentation even possible. All right, let's get started. So a normal is a direction vector, and every vertex of a 3D model has one. And this direction is used to calculate the lighting on a mesh. And generally, it's done by comparing the direction of the light against the direction of the normals. So as you can see from this image, as the angle of the light source increases against the normals, the surface gets darker. So generally, a very simple idea or a simple concept. And these normals are also used to determine the so-called sharpness of an edge. And we generally speak of hard edges when it comes to this. And here you can see two spheres. On the left, one with unified normals, and on the right, one with split vertex normals, causing the faceted look of a sphere. And here are the same spheres with vertex normals visible as well. What's important to understand with the splitting of these vertex normals is that it increases the vertex count of your model. So as you can see, these two spheres, even though they share exactly the same topology and have the same number of polygons, the sphere on the right has significantly more vertices. And in 3ds Max, these normals can be edited through the edit normals modifier. But you can also edit them by smoothing groups, which is most likely the most common way that you have been dealing with vertex normals in the past, if you're a 3ds Max user. There are already some quite common workflows when working with editing these normals, such as foliage and hair cards. And in the simple animation there, you can see a tree on the left has so-called default vertex normals, and the tree on the right has its vertex normals shifted to create a lot smoother and visually more pleasing shading. And this same technique has been used on hair cards and graphs and all kinds of different shading methods. So now that we know what normals are, let me tell you a bit about normal maps. So normal maps store a normal direction each pixel of the image. And commonly these are used to fake high-resolution details on models. But what do you think is the main visual reason why we bake normal maps from high-poly models instead of creating them from 2D sources, for example? I'm going to spoil it for you. It's the edge curvature. Because even though the split vertex normals that you see on the cube on the left has nice definition of shape, it also has extremely unrealistic hard edges because the split vertices locate in the exact same position, causing this unnatural and unrealistic edge. But when we create high-poly models, we generally want that nice, smooth curvature to transfer to the low-poly model we are creating. Seen on the right. And that's all nice, and normal maps are extremely useful, but they have their own problems when it comes to production. First of all, they usually require unique texture for each asset to work properly. There are workflows to reuse normal maps, but generally you need a unique texture. There's the baking process from high to low poly models, which can be time-consuming and overall quite exhausting. And the quality of the normal map is directly tied to the resolution, which can cause issues considering memory and small details. And then there are, of course, different workflow errors. You can come up with different tangent space errors, meat mapping errors, compression errors, basically errors all around. So now we are trying to see if we could get away without using normal maps. And with more processing power that we get basically each year, it usually gives the artists a possibility to use more and more polygons in their work. And we have pretty much come to a point that we could just be chamfering edges. And not only would this create that nice curvature, it would also match the silhouette of the high-poly model a lot closer than the split cube. But again, this doesn't really work as well as we hoped. Because as you can see in this example of a cube with a simple two-edge bevel or two-edge chamfer there, with one smoothing group assigned. So basically no hard edges on the model on the right. What you'd expect is this clean and nice defined shapes seen on the left. But all you get is this messy gradients and overall extremely unpleasant thing to look at. But what if we just adjust the vertex normals of the model? As you can see, all the shading areas are gone. And we get nice defined shape with the same topology and without any trigger there, no normalness or anything. And you might be thinking, OK, what sorcery is this? And really, in this case, all we are doing is that we are averaging the vertex normals of the larger faces to point a single direction. Look at that magic. And here's the comparison of the vertex normals of the two cubes you saw. So on the left is the one with the default vertex normals, and on the right, the one after we have edited it. And as you can see, the default kind of makes a sphere, like a round shape with these vertex normals. And this is generally what causes the gradients, or kind of the light bleeding throughout the edges, making the cube look kind of blobby. But after we have edited these vertex normals, all the transition between the vertex normals happens in those chamfered edges. So we get that nice edge detail, nice curvature on the edges, but still keep the nice shading on the large polygon faces. And now that we know that, all right, we can do something like this, face fading steps in. So what face fading does is that it gives each polygon a weight depending on the surface area it has. So in all, small polygons have little influence on the vertex normals, and large polygons have a large influence on the direction the vertex normals go. And for 3ds Max, there are already multiple scripts you can use to achieve these results. And in Maya, ever since 2015, there's been a built-in option to do this as well. And this workflow works for both organic and hard surface models, so there isn't really reason not to use it. And again, a vertex normal comparison, this time with the default on the left and the face weighting on the right. And as you can see, the face weighted results are almost identical to the average one, causing, again, these nice transitions on the chamfered edges, but still keeping that high-quality shading on the large polygon faces. Where, again, the one on the left is the same blobby mess we saw earlier. And generally, this provides a superior shading in most cases. I didn't dare to say in all cases, but at least in most cases. And in this example, I have here the one on the left is a high poly model, high poly test model I made. And the one on the right is a face-weighted and chamfered test mesh. And as you can see, the results are almost identical. You can see some polygon phases on the one on the right and small issues, but overall, the result is quite nice. And just so that you know that I'm not just coming up with these things, this has already been used in multiple major AAA studios and AAA titles. And I chose these 3 examples here because they have all shared a large number of documentation of their workflow, and I'll be using them as case examples during this presentation. So, for example, the Ready at Dawn, The Order, Creative Assemblies, Alien Isolation, and Star Citizen. But there are, of course, multiple other games and studios that have used this workflow. And as there are multiple different studios using it, there are, of course, multiple different use cases for it. And I'll be going through these in more detail soon, but the first and simplest case is just to use tiling materials with these face-faded normals, so you're not using a specific material or shader for your models. You can also combine face weighting with traditional models, traditional baked models. And the last step, more technical step, is detailing these models with decals, which I'll explain more about later. And you can also use face weighting in your traditional workflows. Generally, this is to reduce the gradients on large surfaces of your low poly model or in the normal map. And this workflow works on mobile as well. If you have the possibility to use some more vertices in your models. All right, let's move on to the first use case, so the tiling materials. So here's the model from Alien Isolation. And you can possibly see the chamfered edges, yes? So you can see how they've used their topology, creating their assets. But what they take note here is the use of the same material throughout the asset. So you see there are multiple different paints by different colors. Generally, this is most likely just one material with some parametrics to change the color. And the same tiling metal or steel material as well. But what's the negative impact of using these tiling materials is, of course, that you don't get any specific edge wear or dirt accumulation in your models unless you have some sort of a smart material that does it for you. And as I said earlier, this workflow can be used on hard surface, like you just saw, but in quite organic models as well. So here are some rocks from the order. And as you can see, they still have that nice high-quality shapes in them, even though they're all using the same materials. This workflow, of course, increase your iteration and variation creating times, as you don't need to retexture and so on each individual asset. Moving on to the next production use case is the combining the face weighting with baked assets. So here again we can see this bookshelf or desk thing, which has been done using face weighting, but all the handles and name tags and smaller hinges and all the small details have been created traditionally and then just combined with the face weighting. And this again leads to a large number of variation with really limited amount of materials and assets. So here you can see different bookshelves and desks done using the same assets and same workflows mentioned before, as well as the tiling materials used to create these assets on the below. By now you might be thinking, what about the really small details, like some rivet lines or every individual screws on a spaceship? So we move on to the detailing with decals step. And this is a workflow used significantly on the Star Citizen because they have large scale spaceships and environments, and it would be basically impossible to have multiple different normal maps for different parts and still keep all the quality consistent. Again, this is a bit more technical workflow step, as it generally requires custom shaders or custom workflows, generally using the G-buffer decals or other UV tricks. In the image here, you can see one of the ships from Star Citizen, and you can just look at the scale of that ship compared to the character there. And you can also see the decal atlas they used on the ship on the right. So using these decals, you can achieve remarkably high textile densities, even on these massive objects. So here's a close-up of the one part of the ship. and it's extremely high in quality. But it's important to understand that also the textile density stays consistent throughout your asset, as you're always using the same atlas texture for creating these, and not spending individual unique UV space for these details. And this workflow can be used on both large-scale ships and vehicles and whatever, but also small-scale interiors as well. So here's the interior of the ship you just saw. And as you can see, you can always see the chamfers quite nicely as well. So excessive use of chamfering there. But what to take note here is those small planes you can see on the dashboard and on the sides of the panels. Here's the render of the same scene you just saw. So all the individual planes you just saw there are either screws, buttons on the desk, rivet lines going through the sides, or all these different details. So we can maybe go back again, so you can memorize this and just look at the crazy amount they use decals to create these high-quality details. Incredible. So the pros of using this so-called medium poly workflow, I don't know if there's a real name for it yet, so I'm just calling it medium poly, is that it's extremely versatile and a fast approach to creating game-ready assets. No more exhausting, exploding your models, transferring to different softwares for baking and so on. All you need to do is a couple of chamfers and use the script to face weight your model. There's also significantly less one-off baked assets, and this of course leads to a lot easier project management, as you have a lot less different files going around. And you can achieve this smooth curvature on objects with massive scale, and also achieve this beautiful high-quality detail using these decal techniques. And this workflow is completely resolution independent as well. So no more MIP mapping or compression issues with your bakes, as you can just use your gradient and be done with it. And there are also, again, less gradients on large surfaces of baked normal maps if you wish to combine this with your traditional workflows. So what are the cons of using this said workflow? Is that, first of all, the level of detail models, LOD meshes, are a lot harder to create because of these chamfers. So it requires some extra planning for your workflow and when creating the assets you want. It gets quite a lot easier if you use three-edge chamfer, so you still maintain the middle point of the edges you're creating. But of course, this increases the vertex count quite significantly. And this workflow also introduces quite a lot of its own performance issues. And probably the biggest one is the subpixel triangles that happen when you chamfer a lot of small edges. There are also possible fill rate issues and so on. So it requires some benchmarking for your project to see if it's a viable option for you guys to use. And it, of course, requires custom tools, be it as simple as the script that does it, or the decal technique, which, of course, is a bit more complex issue. And it's just not the best solution for every object. In some cases, you just decide that, all right, this model is too detailed, too ornate, or whatever that. It just makes no sense to use this type of workflow when the traditional workflow has been proven successful in it already multiple times. Next up, I'm going to move on to the tutorial part of this presentation. And here are the tools I used, so 3ds Max, Unreal Engine 4, and Substance tools. But generally, you can use any content authoring tools as long as you have access to edit vertex normals of your models, and your engine supports custom vertex normals as well. And I'll be using a script by Juan Martinez, who was kind enough to share his face fading script to the community. And you can get it off his website completely free. So, cool thing. All right, but let's move on to the actual mesh creation. So nothing new here, really. It's just the traditional modeling, except you're chamfering the edges. You want to have the smooth curvature going on. And in this test case, I created this like wooden bench type of asset. And as you can see, even with the chamfering, the vertex count for this model isn't really that staggering and could easily be used in a modern-day game. So nothing new here, just the old usual stuff. UVs, again, nothing really changes here. So I just created these simple UVs for my model for the tiling texture. So I made sure that all my UVs are aligned correctly for the wood texture I'm going to apply to it. And in this step, it's also possible to use different kind of triplanar shaders or triplanar materials. And you can basically just skip the UV part as well, because you don't need UVs for the normal maps either. So for some assets, it could be the best choice. And the next, the magic step, is the face fading. And in this case, it's really just one button, make art button there. So all I did was I assigned one smoothing group to my model. And after that, I ran the script, and boom, magic. Here you can see the comparison of the models before and after face fading. So the model on the right is the wooden bench with just one smoothing group applied. And as you can see, there are quite nasty gradients going on all the cube or box-like shapes, but there are also quite massive errors on the flat sides of the end of the bench I created. So, and when the one on the left shows a lot more visually pleasing and correct results as expected. And here's the comparison of the vertex normals before and after face fading again. So as you can see, the one on the right is quite bloppy, messy. The normals are pointing in quite sphere-like directions, whereas on the left, all my large surfaces have had massive influence on the direction of the vertex normals, causing all this smooth and nice shading. And here's the model after I applied my wood texture. I did create a couple masks in Substance Designer for edge wear and dirt, and created this extremely simple, smart material. So you can see some of the brighter edge wear and possibly some dirt in the lower parts of the asset as well. But overall, the visuals are quite nice and something you'd expect from a traditional model. In my example case, I also decided to show you the Decal workflow, but currently Unreal Engine 4 doesn't support custom meshes to be used as decal actors. And this can be you can go around this, creating a specific kind of material, but I'm not really a technical artist or expert on that side, so what I did was go with the bit easier workflow for myself, is just to use 2 UV sets. And the first one is for the tiling material, and the second UV set is for the decals. And I created this wood carving thing on one of the pillars I created. So here you can see the wireframe for the model as well as the UV1, which is the tiling material for my models. So all I did was create a spline in a shape I wanted and made a mesh of that. And then I projected the location of the decal plane onto the actual model, so I don't get any errors on the location considering the tiling materials there. So quite simple workflow in case you don't have access to a shader guru. And this is a full scene. I was kind of hoping to get it ready for assembly, but it's still quite a work in progress. But pretty much all the assets here are using face fading, except for the candles on the chandeliers. I'd say this workflow is relatively fast. Making this scene took me around a week, and really most of it was making the tiling textures. So all the modeling was basically 2 days. And you could also, and I most likely will, choose this up with traditional assets, making a Viking shield there or whatever. And as you can see, the results hold up even close up quite nicely. Sorry for the bit dark images, but hopefully you can see some of the beveled edges there. And here's an image of the decals in the scene as well. So they quite nicely blend into the actual pillar I created. So to recap all that I just told you is that vertex normals are a direction vector, and these directions are used to calculate the lighting on your models by comparing the direction of the normal vector to the direction of the light. Face fading works by fading polygons based on their surface area. So large polygons have large influence on the vertex normals, whereas small polygons have little to no influence. Combining these, we can create this so-called medium poly workflow by chamfering our models and face fading our assets after that. And just like I showed you, there are multiple use cases for this technique. All in all, it's really quite simple and doesn't require any magic. But it's important to remember that it's not a magic bullet. Some assets are not really up for it, and it introduces its own issues considering your production pipelines. All right. Next up, I could take some questions. I still have a couple slides, but they're not really regarding this presentation. So, any questions?
Hi there.
Hey.
Well, thanks for the presentation. Not a question, just a quick comment. You mentioned that Unreal would not have mesh decals. Apparently, the new preview that was just released like 2 days ago will have mesh decals.
All right. Yeah. Well, by the time I was still.
But obviously, yeah, it's not fully in yet. Just saying.
Yeah. All right.
Thanks.
So possibly in the future, we can just use the custom meshes on in Unreal Engine as well, because this is quite new workflow, so it's quite understandable that the engines are quite rapidly catching up to it. All right, any other questions?
Have you tried to use any automated tool for doing also the chamfering and then the vertex normal editing?
Well, yes, you can use, there are, again, scripts for 3ds Max and most likely other content authoring tools. In Max, there's the chamfer modifier, but it doesn't always give the best results. But a script called quad chamfer has quite nice results. And I guess it also has the face fading built in it, so you can just combine the chamfering with the face fading in just one tool.
Thanks.
Any more questions? If not, then thank you, Miro.
I still got a couple of slides, but...
Yeah, and
All
you
right.
can do the slides, of course.
Yeah, thank you. Yes. So I'm part of a service called Game Art Collective, which specializes in training 2D and 3D artists. And we provide mentoring and different online courses as well as live courses for schools and universities and so on. Currently, our mentors have industry backgrounds from Rovio, Remedy, and all the way to Rebellion. Together, we have over 30 years of experience and close to 70 titles published to mobiles and PC and consoles. And for you assembly folks, we decided to give you a bit special offer. So you can get 10% off for the online courses or mentoring that we provide if you email us with the GAC 2016 code. So if you're interested in having a just portfolio review or different mentoring for 3D modeling or 2D art, just check the gameartco.com website for more information. Or if you just want to contact me, you can do that as well. So my nick is Mirbabo at ArtStation. So if you want to follow the stuff I do, you can head there. I'm kind of lazy to update it, but hopefully I'll get better at it. Or you can just shoot me an email as well, in case you picked up something from this presentation and create something cool. Just send me a link to it and I'll check it out. Or if you have any questions about this presentation or this workflow, I can do my best to answer those questions as well. All right. Thank you for the